Hello, and welcome to today's Seed World Strategy webinar. Today, we're going to be talking about seed loading and the innovation that's there. It's called Seed Loading More Than Meets the Eye. My name is Julie Deering. I serve as the editor for Seed World, and today I'm going to be your moderator. We've got two great speakers lined up for you to hear from. But before I introduce them, I'd like to do just a little bit of housekeeping. We will be tweeting from the webinar, so if you'd like to follow along or put your own tweets out there, we're using the hashtag strategy webinar. I'd also like to quickly thank our sponsors, BASF and Syngenta. I also want to let you know that this webinar is being recorded and will be made available online. Now, as we go along, if you have any questions, please don't hesitate to type them in the chat box. We will have the question and answer session at the end, and I'll make sure that your questions are answered by our speakers at that time. All right, so let's go ahead and meet our speakers for today. So we have Christophe Rupert and Amanda Patan. And Christophe is going to be talking about seed treatment components and the science behind the formulations. And then that will be followed by Amanda talking about what to think about to make sure your testing succeeds. And then we'll open it up to our audience for questions and answers. Christophe is the Syngenta Seed Care Application Lead for North America. He's been in the seed and seed treatment industry for more than 10 years and has broad international experience with a background in agronomy and specialization in phytopathology. So you can see here that he's got his bachelor's degree from the Agricultural School of ESA Angers, and I will not try to pronounce the second school, but you can see his credentials there. So. Christophe, I look forward to hearing what you have to say and to share with our audience. And with that, the floor is yours.
Sure. Thanks, Julie. I'm just going to ask you to move on the slides because I can't get control here. So if you can just move on, I'm just going to prompt you to move the slides. Again, thank you for inviting for the today webinar and for the topic we're going to cover today. Because it's really special for me and for what we do actually in our arena to talk about seed loading. It's what we do almost every day, what I keep doing for the last 10 years. And we really think there is a lot to do in there, and it's a key topic because it's not only knowing what's on the seeds, but also how much is on the seeds today. And more we put more components we are going to add to those seeds, more we want to know how much, right? So today I'm going to talk about mainly the drivers and the factors that influence actually seed loading. Not so much about the analytical part because I think we have a nice expert on the call today too to talk about the analytical. But my focus is going to go into, again, technical and technological points that are driving the seed loading and to make sure we really understand what's on every seed. So here on this first slide you can see that of course today there was a lot of evolution around the seeds too. I think that's something we should not forget. There was a lot of evolution around the formulation of the way we treat seeds today, but also in the seeds itself. And the first point I wanted to talk about is clearly the evolution about the way we think about loading a product on seeds. Probably 10 years ago, a lot of the products were still used as a flat rate. So we did not really consider how large, how small, how flat or how round was the seed, but everything was basically on a flat rate. And we have more and more products today that go with specific rates. Also specific rate per crop. It's not just for every seed, and that's a clear big change. So having a specific rate for every single seed. And then one of the second driver, I put it here, it's not really a technical change, but it's something that affects clearly the way we have formulation today, and it's all the regulatory requirements, right? So having products that are more conscious about the way we apply them on those seeds, but also the way people handle the seeds and the treated seeds and the seed treatment product is clearly a key of the way we develop new formulation today, new formulation technology. And then also about the technology performance improvement. So point number 3 is actually clearly aligned with point number 1, because more we are actually going for a specific rate per seed, more we actually also improve our products, right? So we want to make sure they are more efficacious. If you just can come back, please, to the previous slide. So more we want to know how these products are going to be loaded, and the technology performance is clear. So there is more on-target products and all the different actives that are part of those new composition are clearly with higher performance. And then the fourth one is about seed quality. There was also a clear improvement around the seed quality. We don't only talk about potentially the genetic or the trait, but also the pure quality, the physical quality of seeds evolved a lot and helped us also actually to do better seed loading. So it was a key component in these drivers. And then point number 5 about the seed treating technology. So we really had to also align, right? We wanted to have better rates, lower rates, more accurate on seeds. But for that, we had to get some better technology and some improved technology. So a lot of evolution in this arena here for seed treating technology. Is it upstream or downstream operations? There is clearly some evolution in both markets, in both segments. And before the last point, I like also to mention the point about traceability and monitoring, because it's clearly a key factor today. I just like to compare it sometimes a lot to the food industry, right, where people and consumers like to know what's really in their food and what's in every single thing they buy. And we are actually getting in this world for seed treating too. We need to be able to trace in a better way and monitor what's really loading on those seeds. Color is nice, the red is nice, or whichever color is nice, but it's not everything. We also want to know what's really on those seeds. And then the final guidance clearly is those stewardship rules. This comes as a whole around the loading analysis or around the way we want to load something on seeds, because it's also making sure we do it safely. All right? Next slide. So here the point is, on this one, I wanted to explore a little bit more around the two factors about formulation and equipment, because to me the key is not only having the right product, but we also need to figure out how to apply in the right direction. And clearly when we talk about formulation first at the bottom of my page here, there was also a lot of evolution around the way we apply those products, so the way we deliver the products, right? We talk about premix versus custom blends, or blending the product together with individual components in one direction or another. There is probably some more challenges too in the way we blend product together. We talk today about 10, 15, maybe more products on one seed, or active on one seed. And to make it more efficient, there was a lot of evolution around the premix formulation. There we talk also about stability and compatibility. That's another key thing if we need to make sure that we load the right thing on every seed. It needs to be not only stable, but compatible between each other. And then also carryover and shelf life. And that's clearly about the formulation. I'm going to talk later about the seeds too, but we also need to assure that we have a proper shelf life and proper quality at the end of the day, even over time. And the second part of this slide is talking about the equipment calibration, but more than just calibration, there is a lot of evolution in here talking about crop-specific technology. So we have today treating equipment or technologies that are really crop-specific. Calibration is still a key factor, but with the evolution of new automation control, new process monitoring systems, we also remove and we can reduce to a minimum the requirement for calibration. That is actually key in ensuring the right quality for the loading. And then the two last factors about maintaining the equipment is probably key too, and the way we sample actually. So how are we sampling the seeds on those equipment? When do we get them? And what is the direction to do it? And clearly this drives everything what's in the middle of my slide here. Having a higher accuracy, but a poor precision, more we are loading some active on the seeds, or having an inaccurate and a poor position, that's clearly our extreme situation. But where we want to drive it, if we do it right for both formulation and equipment, we go for the high accuracy, but also the high precision. So making sure the right product is on the right target. All right. Next slide, please. Here, this slide here, it's actually what I demonstrate here is nothing really new for what we consider. But it's clearly the driver around everything we need to consider and we need to do to improve seed loading analyzer. And there is a lot of factors that enter in the game here. We can see that there might be a lot more, but those are really the key ones that we consider. The seed load quality is one thing, because starting with a high quality of seeds, and again, it's physical quality, so better calibration, better low dust on the seeds, etc., etc. Those are the type of quality parameter we need to consider to make sure we can do a better loading. And then we talk about the product formulation. Again, there is some quality improvement in there that we can consider, and the technology capability and calibration. That's it's not really at the highest ranking, but today with increased capacities, we also need to consider this one as a key. Operator experience is still one in here. And then the three last one are actually more related to the testing itself, the way we sample the seeds, the way we prepare the test, and the way we do, we have also variability through the testing procedure. So all in all, this graph doesn't really show that, yes, we are at the limit of 20% from the target, right? But it really tries to explain what are the different factors that could be accumulative, and in this situation where we go to the extreme situation of not being on target, right? All right, next slide, please. And then I was talking before about the seed's evolution, right? And the seed itself, because today we load a rate on every single seed. And one key thing to understand from our standpoint is that even with that same crop, that's what we try to demonstrate here, we have so many different seed size, right? And even we consider a given seed per pound that is maybe industry average, whatever, depending on the crops. There is also a lot of variability within those crops. And usually lower the number, larger the seed size, but still we want to load the same amount on every seed. And this is really one of the drivers, not only around the way we calibrate seeds or around the way we handle the seeds, but also around the way we develop new formulation. We want to make sure those formulations are more flexible for all these ranges of seed size, but also drive the industry together. So there is a lot of effort here between the different components or the different players in the industry to make sure we do it right. Okay, next slide, please. And what I had before, it's actually illustrated here when we bring everything together, right? So talking about loading flat rates per hundredweight or flat rates per kilograms, whatever we consider in here, and moving into the direction of milligram of active product per seed. This was clearly a big evolution in the industry. And actually, I like to take the example of soybean. It could be taken across many, many crops. But actually in soybean, we had a really big shift, right, over the last years between using 50-pound bags or a given amount per bag versus using suddenly a unit per bag, moving to 140,000 seeds per bag or whatever is the unit size. And this was also a big driver actually for the loading and for developing new formulation. Because suddenly we entered in this world of trying to get much more accurate than we did it before. But clearly the thing to consider is that we have a big variability. So numbers you see at the bottom of this graph here are the variability of seed size. And even if we consider a given average, is it 2,800 or is it 3,000 seeds per pound, it's actually, it's never going to be, or it's not every day going to be exactly this number. So when we consider a milligram per seed application, you see my green curve, that's really how things work, right? We are moving into a world of small seeds, but actually more seeds per pound, right? And that's where we need to increase our rate. On the left side of the slide, we are moving into larger seeds, so smaller numbers, seeds per pound. And this also means in a given number of seeds per pound, if we dose per pound, we are going to load less formulation or less product as overall volume on this given quantity of seeds. And this was really a key driver. And again, it's something applicable, for all the crops. Thank you. Next slide. And here it looks a little bit a lot of information on this slide, but this is really the different factor influencing formulation today and new recipe, I think, in the seed treating arena. So what we need to start with is probably understanding that the value of the seeds evolved a lot. So the high value seeds, we have a high value target that we want to protect. It's getting really to the world that I probably had on my first slide, where I showed briefly to shock a little bit the fact of showing a little pill. And when we talk about seeds today, we also talk that it's such a high value that we want to protect. So people want to protect the investment in quality traits, genetic and combination, and the quality of the seeds overall. And for that reason, then there is these different products coming in the application. And there is evolution around, we see here, fungicides, insecticides, or nematicides, or even other type of products, biological and whatever we can consider in this arena, as well as additional products that get applied with those efficacy or with those active products. Then the seed size and morphology has another impact on the way we develop this formulation and recipe. Clearly, we don't have the same formulation today that are going to operate across different crops. Then the seed loading uniformity. We talk more about the factor I mentioned before, loading a given rate per seed. But again, we want to make sure we have exactly the same rate on every single seed, even we load it in a continuous flow process. Dustoff is another key arena that clearly drives also the formulation and making sure we improve it in this direction. Equipment calibration is still a little factor here, but again, we mentioned before, it should be something that gets also easier and easier over time. The environmental condition, plant performance, is one of the other key when we develop new formulation. And then we have the little one on the right of the slide here, inoculant, micronutrients, biological, whatever is also going to be added to those existing seed treatment or to those existing product loaded on the seeds are going to be key to understand the future. And the last process I talked about is seed quality and seed safety. We should never forget, whatever we load on the seeds, we want to make sure it's still safe for the seeds, right? Because seed is alive. It's not like, again, a pharmaceutical tablet. But here we are also living and loading something on living organisms. So key, really to keep in mind this key factor. And the two last one around equipment, application, equipment, and process, as well as application recipes. We talk a lot about recipes because it's clearly like baking a cake, right? We want to make sure not only we load it the right direction, but at the end of the day, it's still going to act, and it's still going to be efficacious with the right efficacy in the field. So this is clearly driving the product design today and the product of the future. All right? Next slide, please. So that's it for what I wanted to cover. And again, just for the little word of the end, I think whatever we put on the seeds I mentioned before, we should not forget that every seed need to be able to grow and need to be able to perform in the field. And that's clearly why we do all those different analyses and why we do all those different tests around the industry, and why we also want to improve situations in the future. Thank you.
Great. Thanks so much, Chris. I think you covered a lot of ground there in a short amount of time, and we'll be able to come back and dig in a little bit deeper during the Q&A session. So again, to our participants, if you have any questions for Christophe, please don't hesitate to type them into the chat box, and we'll get to them here during the next part of our presentation. After Amanda shares with us what you need to think about to make sure your seed testing succeeds. Amanda graduated from the University of Arizona in 1996 with a master's degree in ag education with a thesis in entomology. Then in 2000, following her work in insecticide resistance, she began working with seeds at SGS North America. Here, for 17 years, she was the contract laboratory research director, and she was responsible for designing and conducting research studies to evaluate seed amendments. She improved current seed testing methods, developed new testing methods, evaluated mechanical damage caused during seed harvest and conditioning, and evaluated various seed amendments for both physiological and mechanical effects to seed and seedling. Today, she served as the account manager for seed. And with that, Amanda, I'll turn it over to you.
Thank you, Julie. So when Julie gave me this topic, what to think about to make sure your testing is a success or that it succeeds, I automatically thought, what do I need to do in order to assure that my seed quality will remain the same with anything that is newly developed, with any product that might be amended to the seed, and then with any type of testing out there. So the first thought is what are the benefits for seed treatments? Because we want to make sure that the benefits don't diminish when we're applying other things to the seed. So as we're thinking about it, we're thinking about the benefits that they have, the uniform emergence, the protection against pest, increased germination, delaying in germination, making planting more uniform, increasing the safe handling. But we also want to make sure that those components that we're putting into our slurry mix to apply to the seed or putting in over top later on in the treatment line are not being harmed by what we put in there to protect the seed, and that the seed is not being harmed from them, and that they are still being able to do what they can do. So then we first think about the fact that the seed is going to be the delivery system, and that inside the seed we've got all these traits that we have. We have high quality seed that has been modified or not modified, that can prevent drought tolerance. It can help with insecticide resistance and herbicide tolerance. We've got also traits where we're thinking about increased food and feed qualities. So as we're thinking about this, then we're going to put on top of it the different types of amendments that are applied to the seed. So now we have micronutrients, macronutrients, nematicides, insecticides, all of these things going onto the seed with a very limited amount of space. So as most people say, that's a real estate of the seed. And as Christoph was saying, the seed varies in size. So this very inaccurate soybean seed and shows the different types of treatments that we're putting on there. Well, while these are showing layers of the different types of additives into the slurry mix, not all of them will go on as a layer. They'll be into that slurry mix, applied as once, and then maybe possibly applied over later on, especially with biologicals that come into the picture. So that comes to, okay, I have a new product. What type of application am I going to go ahead and think about? So first of all, how am I going to apply this product? So that's the first thing you're thinking about. Is this product going to go into the slurry mix? Is this product an active? Is this product some sort of amendment that is making the safe handling of the seed better? Or is this some sort of amendment that's going to go ahead and allow us to see the colors better, reduce dust off, make it larger so it's easier to plant? So we'll think about the product's function. Then we want to think about the market that the product's going into. Not all products can go into every market. The usefulness of the product. Some new products that are coming out are exciting and very useful in one seed crop market, but not so exciting and useful in another. Then the application, can it be applied? How can it be applied? Is the rate at which I can get an efficacy response actually the rate that can be applied to the seed? The safety handling of the product itself, the storability of the product. So what's the as Christoph mentioned, for the formulation, how well does it stay on the shelf And then also, how well does it, after it's been applied to the seed, how long will it stay active on the seed? And then of course compatibility and efficacy of the product. So to evaluate the product for its function, a lot of the types of equipment thoughts and handling thoughts go into, okay, is it going to reduce dust? Is it going to increase skip when it reduces dust? Is it going to be a slicking agent? Is it going to use to enhance the dry time? Or is it a nutrient supplement? Is it a colorant, a fungicide, insecticide? How is this product going to function, and if it's going to function properly when it's on the seed, even though it may function perfectly fine if you're adapting it from like a foliar product into a seed treatment product. So then you also want to narrow your product market. A lot of times people out there have a product, they think it's going to work great on seed, but will it work in row crops? Will it work in vegetables, long grasses, native grasses when we're thinking about it? We want to make sure we narrow that market to start out with. So again, you'll evaluate the usefulness based on looking at the equipment and the function. What is it intended to do? And then we need to look at it and determine if it is applicable for application. So is the product a granular, a dust, a liquid? All these formulations react differently, and maybe the product works great when it's embedded in the soil, in the fields, but then you want to apply it to a seed. Well, can we put the amount of active that's necessary on that seed in order for it to be efficacious? Can we then put that type of formulation onto the seed? So there's a lot of different types of amendments that can be added to actives to make them so that they work in a formulation. And that's where the formulation chemists come in. So then you want to think about whether or not the application is going to be accurate and how well does it cover. So as you evaluate the safety of your product, you want to look at, is the seed still be able to function to its full potential? So there may be trade-offs on some things. You may decide that the seed can't function to its full potential. You may have a product that is, say, a product that allows absorption of water, which works great in a crop that has very little it has a great water tolerance. But in another crop, such as soybeans, you might actually drown the soybeans. So you want to be thinking about the fact that even though this product will work perfectly on the seed, it may not work on one crop, not allow that one crop to function to its full potential. And then you want to look at germination and how it germinates. Does the seed coating affect how the seedling itself emerges from the seed? And if you put that seedling under stress, can it handle it? Can it handle that growing time and be able to function normally, or does it show effects to the growing potential? Again, you want to evaluate the storability of the product. This is on the seed. For many crops, they carry over a season, so you want to be able to evaluate that. And if it's a living organism on the seed, placed on the seed, then you want to look at efficacy through time. And then you want to evaluate the compatibility of the product and look at it with other products that are on the market, standardly used, to see if there's an issue. So for proper application, this is a Hagie batch treater, which is a simple treater. It is simulating a drum treater that's in the system. It's really easy to use. It's easy to clean. Now there's a lot of different batch treaters out there which are great to utilize and do a perfect job of distributing. I have a couple different ones in our laboratory, and the Hagie does a great job for row crops. However, if you're looking at distribution of your active, you want to really think about how you're applying it and making sure you're actually simulating what is going to be used in the system of application. So many of the seed treatments, they're applied with water. They're water soluble, so it's easy to apply them. Many are dust treatments. Those ones can't be applied in this manner. They have to be applied in a different scenario. And then for the seed application process, you want to look at coverage. You want to see how it works through the application, how it dries, and how quickly you'll be able to apply the product. Because of course in our systems today, you only have a small amount of time between when that chemical is applied and when it goes into the bag. So one item that we look at a lot is the coverage. Now, there are different types of seeds, different dimensions of the seeds. The flats are pretty hard for corn to apply to compared to, say, a round soybean or a round sorghum seed. But sunflowers and corn with the flatter surfaces, indentations makes it a little more difficult, so that's one we'll go to, depending on, of course, what crop it's going to be looked at in. And we look at the coverage. Now, how well does it cover? We look at the appearance. We look at the tackiness and the dry time while we're looking at these applications. So again, thinking about application, we wanted to look at how the active gets onto the seed, how much of the active gets onto the seed. This active itself for seed treatment application verification allows us to look more deeply into the seed and see what has adhered to the coat and did that target application rate become achieved. So for fungicides and insecticides, it's fairly easy to do with HPLC or an LC-MS-MS. So one way that we can do a review of the seed, this is the soybean seed that we've looked at under bulk. So if we're thinking about how well did we apply, say, in a large mixture out in a large seed applicator out in the field, we take a sample and we look at it in bulk to get a representation. So in this, we take a large seed. We take about 50 grams or 50 seeds, 2 sets of them, weigh them out and record. We have to know seed weight to interpret back to milligrams of the active ingredient on the seed. And then we extract from the seed itself. And these are large extraction vials on the bottom where they've got the 50 seeds in them. And you can see that they've been sitting for a while. The soybeans have started to swell. And then we have to go through different filtration methods. So for extraction, there could be a lot of different solvents used depending on the active ingredient. So with the HPLC analysis, we look at this being the final step. So we have an Agilent 1200 series that we call our power horse that will do this more simple type of large amount of active ingredient quite rapidly, and it looks at the wave detector looks at the different types of fluorescing, and we have to use different columns depending on the chemistry itself. So a small aliquot of what has been extracted from the seed itself gets placed into the vials, and the vials are loaded into the HPLC. So with that, it's a mixture of the analytes that are dissolved into this mobile phase as it passes through the stationary phases, and that separates them. And as we look at the separation, for the final outcome, we get a graph that shows us the different spikes at the different locations to allow us to look at the separation of the chemicals and where we have a certain amount of chemistry. So this would be the area that would be counted in order to determine the amount of chemistry of that active that is applied to that seed. So then we take calculations back and we look at that peak of that analyte and take that section and compare it to what we expected to be on the seed, to the seed count, what we extracted from, and the weight to get our final determination of fluid ounces per either weight or per seed. Or if it's milligrams of AI per seed, like we're moving towards for most insecticides. Then we have a Dustoff evaluation that we perform. So after the seed has been determined that there is the adequate amount of treatment applied. Now that's the bulk method that we use there. We can also look at it as individual seeds and just do analysis on each seed and seed distribution rate. So for the Dustoff, again, we take a larger sample, about 100 grams of that seed, run it through the rotational drum that's simulating agitation, and get what we have here is a low dust and a high dust. And on this, we have to have the colorant in there to be able to see the dust in order to show it visually. But we do the glass filters on scales before and after. The humidity and temperature highly have to be controlled in order to determine the amount of dust that you have from 100 grams of seed. Then you back calculate utilizing the amount of seeds you have per pound to determine how many are 100,000 seeds per. So in the industry, we're looking at our different rates to determine what is acceptable. And so we look at that dust rate back calculated. There's also a flowability test. This allows you to treat the seed and then bring it right to evaluation to see how that seed will move. We look at for bridging or stops in the treatment in the seed as it moves through the container. We also look at the weight of the seed at the final end. And basically it's simulating a funnel hopper type planting method, where when we look at plantability, we're looking more at the seed singulation. We're looking at how it runs through the planter itself. So for the plantability test, we're utilizing this planting meter, which is telling us the flow of the seed and seeing if there's skips, doubles, triplicates, singulation. It's looking at the amount of spacing that it will differ from that line when it goes into the field. And then for compatibility of the product, we need to look at how the seed treatment itself mixes and whether or not it affects what's being added to it. So with that, we'll move on to the next compatibility here slide just to show a simple type test for compatibility. So you mix the ingredients together. So in this one, it's actually not seed treatment. This is just a tank mix example. We have here, right here on the middle picture, we have the product that has no settling, and then here we have a product that's settled. Now this is a quick assay to determine whether or not there's any issues with particulation or any issues that might cause the tank not to flow well. But we can do this in seed treatment as well, where we look and see how long can the slurry mix go without being agitated. So in most cases we want to apply that slurry right away, but we know darn well that in the large production systems we apply and mix the slurries routinely, and so we'll have a slurry in there much longer than 24 or 48 hours. So in this process too, we screen it and we look for particulates. So these particulates that are coming out onto the screen will be things that would cause a function failure in the field. So if we have a sprayer, that would cause the sprayers to clog. Likewise, the particulates show that there's a problem with compatibility, or can be. So then we look at the safety of the seed. So if we're looking at all the functions and all the different types of things that we can put together for what goes on the seed, now we want to look at, well, okay, we can put it on the seed. It works well. We know that we can get a great application. Is it safe for the seed? So as we're looking at it, we want to look at germination testing. We want to look at both the standard germination and then germination under stressful conditions. So these are just a couple different types of germination methods. We have a rolled towel planting that's going on in the back here. This is a vacuum planter. This is a crepe cilius paper and a sand test. And then for the evaluation here in the rolled towel, and then evaluation with the sand test. These are typically, depending on which crops you have, a 7-day test, maybe 14, 21, 28, depending on which crops you're looking at, if you're looking at grasses. So for the evaluations, we want to make sure that the seed types are stored. Some seed types, when they're looked at, we want to make sure we're storing them long enough for our storage test of safety evaluation. So some crops only carry over a year, some crops carry over multiple years. So in this situation, we want to look at making sure it will store for that entire amount of time. And so it's critical to determine that this product doesn't cause toxic symptoms right away, but we also want to look at it after it's sat for a while. And then whether or not the product itself is still productive and active when it has been stored for a while. So you look at efficacy through time as well. And then we look and see if the germination and vigor work well. So this is just a couple toxic symptoms that I had pictures of to be able to show. Now most of these are herbicide toxic symptoms, you'll notice, if you do this type of testing. But in the case of phytotoxicity of plants, the processes typically show similar effects, even if it depends where the blockage is going on. So if you have blockage going on right here at the mesocotyl, we have a lot of decay. There's death and dying right there, where in this soybean over here, we're seeing it more at the point of attachment. And then at this one, it's completely causing no growth symptoms ability whatsoever, where this is a normal seedling. And in the processes here, we're looking for all sorts of types of symptoms. We'll look at the root. Down here at the soybean, you've got a blackened tip. You've got a short root. You don't have any extra root hair growth. When you're looking at all these symptoms, you want to make sure that you're seeing that the soybean seedling in this case has the ability to function properly and normally. And then for seed safety trials, as we're looking at them, you want to run them not only in the laboratory, but you'll want to run them out in the field as well. And that'll really help on your efficacy testing to make sure that you're efficacious against either the fungus that you are looking at or the insecticide that you're looking at. So when you evaluate a new product for either any type of enhancement product, you want to look at the seed safety trials. Protectants and polymer coatings need to be evaluated for performance. So you're looking at Dustoff, you're looking at plantability, you're looking at flowability, dry time evaluations. And then for laboratory and field, you want to make sure that you've got your lab tests. Those are typically the cheaper tests that can be gone through time, but then you want to go to the field with it as well and make sure that there's no symptoms happening in the field that are going to cause issues with your actives. And then for your compatibility assessments, it depends which market you're going into, where your product's being applied. If you're wanting to be applying your chemical or your product at the end, maybe it's a biological and it's going over top, you want to make sure that your biological is compatible with the products it's going over top of so that it's safe for it. A rhizobia, a bacteria, all of those are very sensitive to some of the ingredients that are in the formulations that are already applied to the seed. And that could be either the active ingredients, or that could be the filler ingredients, or that could be the polymers or the colorants as well. So you want to make sure that your product won't be harmed by what else is underneath the seed if you're applying on top. Because you got to remember that most formulations are water soluble, and they'll move and affect the biological potentially. So you want to check that out to make sure there's no ill effects to your performance of your product. And then of course you want to evaluate the storability, germination, vigor, and dormancy checking. So a few references. A lot of the seed testing is all in the AOSA rules. And then we're a full-service testing laboratory that does lots of quality assurance, seed treatment research, GLP, feed, and crop. Thank you so much.
Great. Thanks, Amanda. I appreciate you taking the time to walk us through that. And certainly there are a lot of aspects to keep in mind from a testing standpoint when you're looking to bring a new formulation or a new product to market. With that, we're going to go ahead and move into our Q&A session. So we've got a number of questions here, and we'll go ahead and get started. I believe the first couple are for Christophe. So the first one that came in was, what is the acceptable industry range? 0.80 to 120%, or 80 to 120%.
Right. That's maybe, it's a really, thank you for the question, really good question. There is actually no really clear industry standard, maybe the 80-120, but actually we think that with current technology we have a clear way to narrow down this standard, and also depending on the active, actually you may want to clearly narrow it down. I mean, you cannot really just follow this plus minus 20% rule. that maybe was in the past of the time where we had no precise rate per seed. But I think with this technology today, we should be able to narrow it down clearly. Thank you.
Oh, sorry. Sorry, why Syngenta product indexed to 3,000 seeds per pound when the industry standard is 2,800?
Good question. So this is actually the way it is on the label. Yeah? It doesn't mean it cannot be adjusted on a per seed. It's actually not really a huge change, but usually it's just a conversion that needs to be calculated back. And but it doesn't mean also that you cannot apply on a per unit base. That is actually also the way we have a lot of the registration today. So there is a rate per unit that makes it also pretty much easier instead of considering a rate per hundredweight.
And can you tell me a little bit more about, I guess, be more specific in terms of how do today's modern formulations differ from the older formulations?
Yeah, good question too. Thank you. This is actually something I think Amanda addressed a little bit before when she mentioned that we don't have really only liquid formulation. I think this is a big change actually, already moving from more solid formulation to liquid formulation. And one of the second thing was also moving more from solvent-based formulation to water-based formulation. That makes them also safer to people. And today actually the biggest evolution I would think about formulation technology is moving into more premix generation of premix formulation, where we have combinations sometimes having up to 6, 7, or 8 actives in one formulation. So this was one of the other big driver, and clearly more to come in the future with considering not only chemical type of formulation but biological formulation too.
Okay, and can you explain slip and what that means? And I'm not sure if that was directed towards Amanda or to Christophe.
Sorry, can you repeat the question?
Sorry. Can you explain what slip is? And I wasn't sure if that was directed towards Christophe or to Amanda.
Going to let Amanda start on it if you want to.
Okay, I think the question is referring to a slip agent, and it is more thought of in the polymer world, maybe not necessarily seed treatment application itself, but an agent that allows the seed to flow or move quickly, which would be a slipping agent.
Gotcha. And how do you measure dry time in the lab, Amanda?
Okay, so that can be measured several ways, but one of the ways it's measured is a blot test, where you're looking at the amount that will come off of the product through time. So there's multiple ways that can be done though. You can look at moisture content on the seed. We don't have that technology here, but there's other types of factors, but in many cases it's a timing and checking periodically to see how long until it's sufficiently dry to allow it to move on to, say, a bagging or through the system.
Okay. And does visual colored dust always correlate to AI on the test filters?
Okay, so for this, it's one of those things where it's the amount of dust that comes off, it doesn't correlate necessarily to the AI. So what we've done in the past is we've taken some of these filters and looked for the AI concentration in the filter. So we'll do that with either an LCMS or an HPLC, depending on the amount of active that should be dusting off. And so in most cases, it's the more sensitive equipment that we utilize. And so, no, the amount of dust does not always correlate. You can have seeds, like Christoph had mentioned during his talk, that seeds themselves, we're coming up with better cleaning techniques, which allow us to apply seed treatments more uniformly, more easily. But a lot of the seeds come straight out of the field, and they could be very dirty. They get processed through, of course, a processing equipment, and still they could be very dusty. So there's different dust levels depending on where your seed was produced and which production plant it went through. And in that process, we get dust from our controls that we run, sometimes a lot more than after we apply a treatment to it. So if we run a control without anything on it, and then we run a control that has, say, just the colorant and the total slurry mix of everything except for the active in it, when we run those controls, we can see a huge reduction just from applying the treatment to the seed, because we're reducing the amount of dust that was actually on the seed itself. So yes, it's an important factor to think of, is that no, that dust does not always correlate to what the AI coming off is.
Great. And this next question is to both of you. So Christoph, I'll let you take the first stab at it. In terms of reducing dust, can you still accurately measure dust, even below the detection levels of the current methods? I'm going to say HUBOC, or do we need a different revised dust testing method?
It's really a good question. I think this goes really beyond the topic of loading, clearly, but I think it's also key. Today we have these techniques that yes, brings us some data, and brings us some I would say good data too, because there was clearly nothing existing before. And actually, something to mention maybe to the audience of people who don't know actually maybe the tool or the method we use. It's something that is extracted from the pharmaceutical industry, where people use sometimes to use dust measurement in either drugs or tablets, or sometimes powders actually, or whatever type of solid formulation. So this is actually where it comes from, and of course in this industry it was pretty easy to set standards. Now, in the seed treating industry, it's clear that today we reach sometimes limits where we cannot detect anymore, or we have hard time to measure. Now, is this a bad thing? I think it's also a positive. I think we need also to take it this way, that we improve so much some of our formulation, or so much some of our treating process that we cannot detect. Behind the scene, actually, there is a lot of other evolution coming in this world. So I can't really disclose information on which technology, but there is clearly a technology that exists outside there where you can measure up to the nanograms of dust concentration in air, etc. And that's probably one of the directions where it might go if I would say the IBAC or this Dustoff method today is getting limited to what we try to do.
Amanda?
Yeah, and I guess when I first started doing dust-off testing, the HUBOC wasn't even in the picture. So if we think about back a few years, and we think way back, we had some issues that happened in the agricultural world that caused attention in the European Union to the dust-off amounts. And so in that process, it was chosen that this method was going to be our universal method for the European Union. So in that aspect, we're pretty much stuck with that method until a new method is allowed. But it is not necessarily the best method by any means to determine dust levels. As Christoph mentioned, there's new technologies out there. There's even some old technologies out there that are better methods and can detect much lower amounts of dust. Ones that are more used for things like safety and chemical exposure.
Great, thank you. And is there a certified and or approved seed lab that can perform a seed loading analysis test, and how different are the results between labs? That is then followed by, if you use the exact same seed-treated sample, are all seed labs using the same AI's extraction technique? There's multiple questions in that submission.
Okay, I'll stab at it. A list of accredited approved labs for seed loading analysis testing. There are lists of accredited and approved labs for Heubock testing and Dustoff testing in the European Union. There are labs that are ISO 17025 certified, and then there are labs that are in the seed testing world approved and accredited for international seed testing standards. For loading analysis tests, that type of certification, as far as I know specifically, does not exist for seed loading analysis. However, the tests themselves are fairly routine tests in the laboratory and can be certified under an ISO system and accredited under different systems. How different are the results between labs if they're using the exact same treated sample? I haven't done a proficiency test to find out. Christoph, you might have knowledge on that. But if they're using the exact same method, the exact same extraction technique, it depends on how uniform your seed treatment is on that sample, on whether or not you're going to get a very similar rate. But I would say that you're going to be within the tolerances that's allowed for the application. And then are all seed labs using the same AI extraction techniques or protocols? No, they are not. The extraction techniques and protocols a lot of times can come from the sponsor companies, and those in particular would come directly from the sponsor, and then yes, the labs would be using the similar technique mandated by the protocol. But if they were developed by the laboratory themselves, then the methods would vary. Julie, let me know if I missed anything.
Christoph, do you have anything to add to that?
Yeah, no, just briefly. I think what Amanda went through is clearly, I fully agree with the situation. I think what we do on our end, actually, just to complete, we clearly do a lot of across labs monitoring, across labs also at least yearly testing to make sure we still align on the quality of the methods and the quality of the analytics. There is also something else to consider, I think, in the future. If we talk about this certification or whatever, lab certification, we are not only loading only chemical on the seeds anymore, right? We have a lot of new products, biological, etc., and that's another arena of work. I think that is going to come along with either lab certification or method certification. It's also how to proficiently be able to load or to measure through analytics the loading of non-active or non-chemical based products. That's one of the next evolution. But going back to the question itself, again, there is a lot of work in this area, and it requires actually constant adaptation, because not only the chemical actually change, but also the seed itself, right? So we have all those changes around the seed that might actually impact loading, or that might impact the analytic and the final results that we need to clearly monitor, is it season to season, or sometimes more than one time during a season. Thank you.
Thank you. And I've got time for one more question that I'm going to pose, or just to ask, and then we'll need to begin to wrap up here. So is a generic AI the same as a branded AI? For example, imidacloprid, Macho with Bayer versus Macho with Alba.
Yeah, I can start briefly on this one. If really we talk about basically the active, and we think we try to compare a name to a name, maybe we're going to say the same, right? But what I would go back is maybe to my original topic I presented today is the formulation. And this is where there is a clear difference between whatever we consider in the market. I'm not going to mention any name of product or whatever. So there is a difference between formulation technology. And I think today this makes a difference, right? It's not only considering the activity or the active product in a given, what we try to load on those seeds, but considering the effect of those given formulation on the final efficacy. There is a lot of work around that, but we don't really talk a lot about it. But the composition of the formulation is key in the final efficacy too.
Thank you. Amanda, do you have anything to add there?
I totally agree with Christophe. The AI may be identical, or it may be just slightly different with how it is structured chemically. But in most cases, if it's calling it the same AI, it should be identical. But the differences between one brand over another are going to vary greatly in what the inert material is and what the company confidential products that are in that, that chemical are for the formulation.
Good. That's a good question. Well, I want to thank each of you for your time and sharing your expertise. I really appreciate you joining us today. And I also want to, again, thank our sponsors, BASF and Syngenta, for their support of this event. And, of course, thanks to all of our participants for your interest. If you have any questions or comments, please don't hesitate to put those in the survey part after this is over, and our team will be taking a look at those and passing them along to the appropriate people. So this webinar will be made available on seedworld.com, I believe tomorrow, and also provided in a podcast format. Again, we are live on social media at Strategy Webinar. And thank you so much to my team behind the scenes who have made this webinar possible. This is Julie Deering signing off.